Hello students, welcome to this lecture, One Polynomials. So here we will discuss now that you have seen that a polynomial of degree 1, degree 2 or degree 3 looks like. Okay, so we have studied about the polynomial of degree 1 that is known as linear polynomial, the polynomial of degree 2 that is known quadratic polynomial, and the polynomial of degree 3 that is known as cubic polynomial. Okay, so can you write down a polynomial in one variable of degree n for any natural number n? Okay, a polynomial in one variable x of degree n is an expression of the form an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a1x plus a naught. Okay, where a naught, a1, a2 dot dot an are called constants. Okay, and n does not equal to 0. So a1 an this does not equal to 0, and a1 a2 dot dot an are constants. So in particular, when if a naught is equal to a1 is equal to a2 is equal to a3 dot 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 is equal to an is equal to 0. Okay, when all the coefficients of x to the power n, x to the power n minus 1, and dot 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 x and x to the power naught. Okay, x to the power 0. While the coefficients is equal to 0, so while the constants are 0, then we get the zero polynomial. We get the zero polynomial, which is denoted by 0. And what is the degree of what is the degree of the zero polynomial? So the degree of the zero polynomial is basically not defined. So note it down. The degree of the zero polynomial is not defined. Okay, and then so far we have dealt with polynomial in one variable only, and we can also have polynomials in more than one variable. For example, we can take a polynomial with more than one variable, like x square plus y square plus x y z, where the variables are x, y, and z. This is actually a polynomial in three variables. And similarly, p to the power 2 plus q to the power 10 plus r, where the variables are p, q, and r. Okay, so this is also a polynomial in three variables p, q, and r. And here u cube plus v square, this is where the variables are u and v. Okay, so this is also a polynomial in two variables u and v. Okay, so these are polynomials in 3 and 2 variables, so respectively. So you will be studying such polynomial in detail later. So in this chapter, that will not study about a polynomial in more than two variables. Okay, so basically here we'll study basically a polynomial in one variable. So here we'll discuss zeros of a polynomial. Zeros of a polynomial. So we consider the polynomial p of x. This is equal to 5x cubed minus 2x square plus 3x minus 2. Okay, so we consider the polynomial p of x. This is equal to 5x cubed minus 2x square plus 3x minus 2. So if we replace x by 1 everywhere in polynomial p of x, then we get p of 1. This is equal to 5 times 1 cube minus 2 times 1 square plus 3 times 1 minus 2. Okay, so p of 1, this is equal to actually 5 times 1 cube minus 2 times 1 square plus 3 times 1 minus 2. And this is equal to 5 minus 2 plus 3 minus 2. Okay, and this is equal to actually 4. So here we say that the value of p of x at x equal to 1 is 4. Okay, so p of 1 is equal to 4. That means the value of the polynomial p of x at point x is equal to 1 is 4. And now similarly here p of 0, this is equal to actually 5 times 0 cube minus 2 times 0 square plus 3 times 0 minus 2. And this is equal to actually minus 2. Okay, so here the value of the polynomial p of x at point x equal to 0 is basically minus 2. Okay, so can you find p of minus 1? So I hope you can find p of minus 1. So if we find now p of minus 1, so p of minus 1, this is basically equal to 5 times minus 1 cube minus 2 times minus 1 whole square plus 3 times minus 1 minus 2. Okay, and this is equal to actually minus 5 minus 2 minus 3 minus 2. Okay, and this is equal to minus 12. So the value of p of x at point x equal to minus 1 is equal to minus 12. So now let us see some example. So here find the value of each of the following polynomials at the indicated value of the variables. Okay, so here we have in first one p of x is equal to 5x square minus 3x plus 7. Okay, and we need to find the value of p of x is equal to 5x square minus 3x plus 7 at point x equal to 1. Okay, and then in second one we have this polynomial q of y is equal to 3y cube minus 4y plus square root of 11. Okay, and we need to find the value of q of y at point y is equal to 2. Okay, so this polynomial is basically a polynomial in variable y. And then in next one we have p of t is equal to 4t to the power 4 plus 5t to the power 3 minus t square plus 6. Okay, and we need to find the value of p of t at point t is equal to a. Okay, so p of x, so let us see a solution. So p of x is equal to 5x square minus 3x plus 7. And then the value of the polynomial p of x at point x equal to 1 is given by p of 1 is equal to 5 times 1 square minus 3 times 1 plus 7. Okay, and this is equal to 5 minus 3 plus 7, and this is equal to 9. So therefore the value of p of x at point x equal to 1 is basically 9. Okay, and then say for second one, here in second one we have this polynomial q of y is equal to 3y cube minus 4y plus square root of 11. Okay, then the value of the polynomial q of y at y is equal to 2 is given by q of 2 is equal to 3 times 2 cube minus 4 times 2 plus square root of 11, and this is equal to actually 24 minus 8 plus square root of 11, and this is equal to 16 plus root over 11. Okay, so the value of q of y at point y is equal to 2 is 16 plus root over 11. Okay, and now let us find the value of p of t at point t is equal to 1. Okay, so here t is equal to a. So the value of the polynomial p of t at point t is equal to a is given by p of a is equal to 4a to the power 4 plus 5a to the power 3 minus a square plus 6. And now consider the polynomial p of x. This is equal to x minus 1. So what is x? What is the value of p of x at point x equal to 1? So what is p of 1? So note that p of 1, this is basically equal to 1 minus 1, and this is equal to 0. Okay, so p of 1, this is equal to 0. So as p of 1 is equal to 0, so we say that 1 is a 0 of the polynomial p of x. Okay, so if p of some point x equal to a is 0, then x equal to a is basically called 0 of the polynomial p of x. Okay, so by using this example, basically we want to give a definition of 0 of the polynomial. Okay, so here we actually get p of 1 is equal to 0 for this polynomial p of x equal to x minus 1. Okay, so here p of 1 is 0, therefore we say that 1 is a 0 of the polynomial p of x. So similarly you can check that 2 is a 0 of the q of x. Okay, but q of x is basically equal to x minus 2. Okay, so similarly you can check that 2 is a 0 of the q of x, where q of x is basically equal to x minus 2. So in general we say that a 0 of the polynomial p of x is a number c such that p of c is equal to 0. Okay, so what is 0 of the polynomial? So in general we say that a 0 of the polynomial p of x at p of x is a number c. Okay, so 0 of the polynomial p of x is nothing but a number c such that the value of the polynomial p of x at point x equal to c is 0. Okay, so that means we say that a 0 of the polynomial p of x is a number c such that p of c is equal to 0. So you must have observed that 0 of the polynomial x minus 1 is obtained by equating it to 0. Okay, that is x minus 1 is equal to 0, and which gives us x is equal to 1. So which gives us x equal to 1, and we say p of x is equal to 0 is a polynomial equation, and 1 is the root of the polynomial equation p of x is equal to 0. Okay, so we say 1 is the 0 of the polynomial x minus 1, or root of the polynomial equation x minus 1 is equal to 0. So you should keep on your mind what is basically 0 of the polynomial and what is the root of the polynomial equation. Okay, so here we have a little bit different of 0 of the polynomial and 0 of the polynomial equation, root of the polynomial equation. Okay, so for case polynomial we use this odd 0. Okay, 0, this odd we use for case of a polynomial, and for case of a polynomial equation, that case we use this odd root. Okay, so root of the polynomial equation and 0 of the polynomial are basically same thing. Okay, so you must have observed that the 0 of the polynomial x minus 1 is obtained by equating it to 0. Okay, and that is x minus 1, this is equal to 0, and which gives us x equal to 1, and we say that p of x is equal to 0 is a polynomial equation, and 1 is called the root of the polynomial equation p of x is equal to 0. Okay, so we say 1 is the 0 of the polynomial x minus 1, or a root of the polynomial equation x minus 1 is equal to 0. So note it down. What is 0 in general? So in general, we say that a 0 of a polynomial p of x is a number c such that p of c is equal to 0. Okay, so note it down. This definition is very important definition for finding zeros of the polynomial. Okay, and this is actually our topic of this lecture. Okay, zeros of a polynomial p of x. So this is our main topics of this lecture. So for the definition of a zero of a polynomial, basically we say that a zero of a polynomial p of x is a number c such that p of c is equal to 0. Okay, and then now we consider the constant polynomial phi. So constant polynomial phi. So can you tell what is 0 is? Okay, what is 0 is? So it has basically no 0, because replacing x by any number in 5x to the power 0 still gives us 5. Okay, so in fact a non-zero constant polynomial has no 0. So if we now have a constant polynomial, then you can say it has no 0. Okay, and why it has no 0? The reason is it has no 0 because replacing x by any number in 5 times x to the power 0 still gives 5, but getting a 0 of the polynomial, getting a 0 of the polynomial p of x, so 0 of the polynomial p of x is basically a number c such that p of c is equal to 0. Okay, but here in this case, for a constant polynomial 5, here after replacing x by any number here, we always get 5x to the power 0 is 5. Okay, that is why the constant polynomial 5 has no 0. So in general, in fact, a non-zero constant polynomial has no 0. Okay, so in fact a non-zero constant polynomial has no 0. And what about the zeros of a zero polynomial? So you have studied what is zero polynomial. Okay, so when the coefficients of the expression a n x to the power n plus a n minus 1 x to the power n minus 1 plus dot plus a2 x square plus a1 x plus a naught are equal 0. Okay, the coefficient equal 0, that case we get a zero polynomial. Okay, and the zero polynomial is denoted by 0. Okay, and we can write 0 polynomial as 0 times x to the power 0. Okay, so here for any value, any real number, for any real number, here for every real number is a 0 of the 0 polynomial basically. Okay, so every real number is basically 0 of the 0 polynomial, because every real number, for every real number, the 0 polynomial always gives us 0. Okay, that is why every real number is a 0 of the 0 polynomial. Okay, so now let us see example. So check whether -2 and 2 are zeros of the polynomial x plus 2. So in this example, basically we have given this polynomial x plus 2. Okay, and we need to check whether -2 and 2 are zeros of these polynomials. Okay, well, how to check it? So let us see how to check it. So here, first of all, let p of x, this is equal to x plus 2. Okay, so let p of x is equal to x plus 2. And then we substitute the value of x. Here basically we replace x with 2. Then it gives us p of 2 is equal to 2 plus 2. Okay, and this is equal to actually 4. So here p of 2, this is equal to 4, and it does not equal to 0. But if x is equal to a is a 0 of the polynomial p of x, then p of s would be 0. But for x equal to 2 value, here p of 2 is equal to 4, that does not equal to 0. Okay, so x is equal to 2, this is not a 0 of the polynomial p of x is equal to x plus 2. In fact, if we substitute the value of x is equal to -2 in polynomial p of x is equal to x plus 2, then we get p of -2. This is equal to actually -2 plus 2, and this is equal to 0. Okay, so p of -2, this is equal to 0. So here -2 is basically 0 of the polynomial x plus 2. Okay, so -2 is a 0 of the polynomial x plus 2, but 2 is not the 0 of the polynomial p of x is equal to x plus 2. Okay, so -2, this is a 0 of the polynomial x plus 2, but 2 is not. And now let us see next example. So in next example, here we have to find a 0 of the polynomial p of x is equal to 2x plus 1. So in our previous example, there we have actually checked whether the given two numbers are zeros of the polynomial p of x. Okay, so that case basically we check by using this concept. Okay, that case we first of all let p of x is equal to x plus 2, and then we replace the value x is equal to 2 in polynomial p of x, then we get actually non-zero number. Okay, that case we said x is equal to 2, this is not a 0 of the polynomial p of x is equal to x plus 2. Okay, but here we get p of -2 is equal to, that is 0. So -2 is basically 0 of the polynomial p of x is equal to x plus 2. Okay, so now here in this example, basically we need to find a 0 of the polynomial p of x is equal to 2x plus 1. So here in this example, we do not check whether the number are 0 of the zeros of the polynomial. So basically here directly we need to find a 0 of the polynomial p of x is equal to 2x plus 1. Okay, students, so let us find. So finding a 0 of p of x is the same as solving the equation p of x is equal to 0. Okay, so finding a 0 of p of x is the same as solving the polynomial equation p of x is equal to 0. So now here we have given the polynomial p of x is equal to 2x plus 1. Okay, so here we have given polynomial p of x is equal to 2x plus 1, and we need to find the 0 of this polynomial p of x is equal to 2x plus 1. So now if we solve the equation 2x plus 1 is equal to 0 and we get some value of x, okay, so that is actually 0 of the polynomial 2x plus 1. Okay, so 2x plus 1, this is equal to 0, gives us x is equal to minus 1 by 2. Okay, so 2x plus 1 is equal to 0. It gives us x is equal to minus 1 by 2. So minus 1 by 2 is a 0 of the polynomial 2x plus 1. Okay, so minus 1 by 2, this is a 0 of the polynomial 2x plus 1. Okay, so this is a 0 of the polynomial 2x plus 1. So now p of x is equal to x plus b, where a does not equal to 0 is a linear polynomial. Okay, so this is actually a linear polynomial. Okay, so how can we find a 0 of the polynomial p of x? So basically, how can we find 0 of the linear polynomial p of x is equal to x plus b, where a does not equal to 0? So in example 4 may have given you some idea. Okay, finding a 0 of the polynomial p of x amounts to solving the polynomial equation p of x is equal to 0. Okay, so in previous example that you have actually given you some idea how to find a 0 of the polynomial. Okay, so finding a 0 of the polynomial p of x is the same as the finding the roots of the polynomial equation p of x is equal to 0. Okay, so now p of x is equal to 0 means x plus b is equal to 0. Okay, where a does not equal to 0, and it implies x is equal to minus b, and it implies x is equal to minus b upon a. Okay, so the 0 of the linear polynomial x plus b is basically minus b upon a. Okay, and so x equal to minus b upon a is the only 0 of the polynomial p of x, and that is the linear polynomial has one and only 0. Okay, so if we have a linear polynomial, then for a linear polynomial it has always one and only 0. Okay, so for linear polynomial always 0 exists, and the number of 0 is basically 1, that is unique. So for a linear polynomial you will get unique 0. So now we can say that 1 is the 0 of x minus 1. So x minus 1 is here linear polynomial. Okay, so 1, if we substitute the value of x equal to 1 in this polynomial x minus 1, then you get 0. Okay, so you can easily say that 1 is the 0 of the polynomial x minus 1. And similarly, minus 2 is the 0 of x plus 2. So minus 2, this is 0 of x plus 2. Okay, so now let us verify whether 2 and 0 are the zeros of the polynomial x square minus 2x. So in this example, basically we need to verify whether 2 and 0 are the zeros of the polynomial x square minus 2x. So basically we have given this polynomial. Okay, so we need to check whether 2 and 0 are zeros of this polynomial. So how can we check it? So for checking whether 2 and 0 are zeros of the polynomial, you need to find the value of p of you need to find the value of this at point x equal to 2 and the value of this at point x equal to 0. Okay, so let us see how to find how to check whether 2 and 0 are the zeros of the polynomial x square minus 2x. Okay, so first of all we let p of x, this is equal to x square minus 2x. Okay, we let here p of x is equal to x square minus 2x, and then p of 2, this is equal to 2 square minus 4, and this is equal to actually 4 minus 4, and this is equal to 0. Okay, so p of 2, this is equal to 0, and then p of 0, this is equal to also equal to 0 minus 0, that is equal to 0. Okay, hence 2 and 0 are the both zeros of the polynomial x square minus 2x. Okay, so 2 and 0 are the both zeros of the polynomial x square minus 2x. So now let us now list our observations. So here let us list some observations. So here a 0 of the polynomial need not be 0. Okay, so a 0 of the polynomial need not be 0. So you can take a polynomial x plus 1 is equal to 0. It implies x equal to minus 1. So here you get a 0 of this polynomial x plus 1 is a non-zero number. Okay, so a 0 of a polynomial need not be 0, and 0 may be a 0 of the polynomial. So you can take this polynomial x square. So x for this polynomial, the 0 of this polynomial is 0. Okay, so 0 may be a 0 of a polynomial. And third point, every linear polynomial has one and only 0. So we know the general form of linear polynomial, that is ax plus b. Okay, and the 0 only one and only 0 of this linear polynomial is actually x equal to minus b upon a. Okay, so every linear polynomial has one and only 0. And fourth point, a polynomial can have more than one 0. So if we take a quadratic polynomial, then in that case you get at most 2 0. Okay, and if we take cubic polynomial, then you will get at most 3 0. Okay, so a polynomial can have more than 1 0. And for example, you can take x times x minus 2. Okay, here for this polynomial, the zeros are x equal to 0 and 2. Okay, so 0 and 2 are the zeros of this polynomial x times x minus 2. Okay, so a polynomial can have more than 1 0. So basically we have to note it down. Okay, a 0 of a polynomial need not be 0. 0 may be a 0 of polynomial. Every linear polynomial has only 1 0. Okay, and a polynomial can have more than 1 0. So this is all about this lecture. I hope all the facts and all the concept are clear to you. Okay, so I stop here this lecture. Thank you very much to all of you.